Okay, so looking at this, there are a lot of different ways you can proceed. I mean, some people might say, oh, we'll read left to right. We'll start left to right. We'll do 9 minus 6 and then 3 minus 7 and add the 4. Or 3 times 7 and then add the 4. Unfortunately, that won't give you the right answer. There are several other ways you can approach it, but unfortunately, many of them will give you different answers. And as we said, there are often problems that have many different ways of solving them, but there's still only one right answer for each problem. So we have to be able to guarantee that when two people do this problem, they get the same answer. And the way we go about that is using the order of operations. Now, a lot of people mistakenly view the order of operations as a set of steps or rules. And that's not really what they are. What they are, technically, is levels of priority. What they're saying is when you're looking at a problem and you see different things, certain things take priority or have to happen before others. So the highest level of priority is something called enclosing symbols. Many of you probably heard this referred to as parentheses. And the parentheses is one form of enclosing symbol, but we're going to see a few others before the day is out. Second level of priority are exponents. Exponents include two basic things: powers, which we've looked at a little bit, and roots. Third level priority, if there's no more enclosing symbols that have to be done and no more exponents, then we'll multiply. Now we talked about how multiplication and division are the same operation, just one's going forward, one's going reverse. So multiplication and division being the same thing, they happen at the same time. They're the same priority. And finally, 4, the last thing that happens, if there's nothing else to do, then we can add. And then, of course, subtraction goes with the addition. So looking at our problem up here, are there any enclosing symbols? No. Exponents? No. Multiplication and division? Yes. We have 6 times 7. Now, some people ask, well, is that 6 times 7? Or is that negative 6 times 7? And the answer is yes. Whatever's easiest for you to view it as. Now, we haven't talked about negatives yet, so we're going to do it as we're subtracting 6 times 7. Now, in this problem, we're going to end up dealing with negatives anyway, but you could view it as a negative 6 times 7, but to make it work that way, what you would have to do is this. You have to change this into plus a negative 6. And then it's negative 6 times 7, and you're adding it. Otherwise, we can treat it as 6 times 7, and we are subtracting the 6 times 7. So anyway, what is 6 times 7? 42. So we take out the 6 times 7, replace it with a 42. Everything else in the problem stays the same. Nothing else changes for now. Is there any more multiplication or division? No. So we move down to the next level of priority, the addition and subtraction. And we have one of each here. Which one has to happen first? Well, if we have more than one thing on the same level of priority, then we do work left to right, just like reading a book. So going left to right, we have 9 minus 42, which is negative 33. Then it's negative 33 plus 3 is a negative 30. Let's do an example, maybe just a little bit more difficult. There, just a little bit more difficult. Yeah, we'll do this just to make it interesting. Looking at this one, it looks like it's kind of a monster, but it really isn't that bad. So looking at it, do we have enclosing symbols? Yeah, we have a couple of sets of parentheses. Remember, we said when there's more than one thing at the same level, we work left to right. So working left to right, the first parentheses we see is this one right here. Now to figure out where we're going to focus, we got to figure out where its other end is. This one's facing the wrong way, isn't it? So that can't be its other end. This one's facing the right way, but it corresponds to the closest one, which is that. So to get to the other end, we got to go all the way down here. So that's our first set of enclosing symbols. And you might be saying, but there's some inside there, right? Well, inside this yellow box now, inside this set of parentheses, our order of operations still applies. We have to ask, are there any other enclosing symbols? And yes, there is. There's another set of parentheses right here. So now we focus in on that set of parentheses, inside the blue box, if you want to call it that. Inside that set of parentheses, what do we have to do first? Is there any other enclosing symbols? No. Exponents? No. Multiplication, division, multiplication. 2 times 3, which is 6. Now notice I take the 2 times 3 out, replace it with 6. Everything else in the problem stays the same. Why did they write such a big problem so they got to rewrite this crap every time? Now we're still focusing inside this set of parentheses here. There's only one thing left to do, which is add. 4 plus 6 is 10. Now we have that set of parentheses down to a single number. Do I need the parentheses anymore? No. Anytime I reduce an enclosing symbol to a single number inside of it, we don't need the symbol anymore. So we can remove the symbol. Now in the case of parentheses, there's nothing that we have to do. We just remove it. Some enclosing symbols will actually have something we have to do in order to get rid of them. So I actually kind of combined two things there. I added the 4 plus 6, and then I also removed the parentheses. So now we're done with that set of parentheses. We're done with that enclosing symbol. We move back out to this one. Inside there, are there any other enclosing symbols? No enclosing symbols yet. Are there exponents? There is an exponent. We do have to do that next. 3 squared, which is 9. Next, any more exponents in there? No. Multiplication or division? There's a few of them. So again, we go left to right. We'll start out with the 18 divided by 9, which is 2. Remember, multiplication and division are the same level, so we go left to right with them. So now keep going here. 12 divided by 3 is 4. And then 4 times 4, which is 16. No more multiplication or division inside that parentheses. So we're down to our lowest level of priority in there, which is addition and subtraction. So we're going to go left to right. That's all that's left. What's 5 minus 2? 3. What's next? 3 plus 16, which is 19. And then 19 minus 10 is 9. And then 9 plus 5 is 14. Now I'm going to show removing the parentheses here on this one in a separate step, because here, when I remove the parentheses, there is something I have to do. Can anybody see what it is? I've put in multiplication. This 3 was in front of that parentheses with no operation there. That's implied to be multiplication. So when I remove the parentheses, I have to make sure I've signaled somehow that there's multiplication there. Now there are absolutely no more enclosing symbols. Any more exponents? No. There is a multiplication. 3 times 4 is 42. And now it is all addition. So 7 plus 42, 49 plus 8, 57. Now I did a lot of writing there. I rewrote at every step. I did that on this first example just so you see. Technically, that is how you should do it. But you can see that takes a lot of space and paper, and it took a lot of time. Rewriting it at this point gives you guys time to, if you're taking any notes, to catch up with me a little bit. I'm probably not going to do that on too many problems. I'm going to put one up here, and I'm going to let you guys try it in your notes, and then I'll come back and I'll show you how I do some shortcuts so I don't have to rewrite it every time. So let's do... one of those days where you just can't think. Every day. Give that one a shot in your notes quick, and we'll talk about it in a... Okay. So, we have multiple enclosing symbols. That's the first one we encounter going left to right, and there's its other end. Inside there we have other enclosing symbols, which is this one is the first one we run into. So there's where we're going to start. Inside that one, are there any enclosing symbols? No. Exponents. Yes, we start out with the 6 squared, which is 36. Now I get asked all the time, could I just do both of them at once? Well, in this case, you could get away with it, but sometimes you can't. So it's safest to do them one step at a time. Now, I'm not going to rewrite this problem every step again. I'm going to do a couple of shortcuts. And the first one is going to come right now. What's the next thing I need to do? 2 squared, which is how much? 4. So I'm just going to erase the 2 squared and put in a 4. Pretend I rewrote the rest of the problem. Now, if you're trying to keep up in your notes, writing down that whole thing, I realize you're not going to be able to do that with me not taking the time to rewrite it. But if you want to put that in your notes that way, just go back to the recording and pause it and write the whole thing just And the next line, rewrite this whole thing as it appears here now if you want to do it that way. Now, I'm still inside that set of parentheses. What's next in there? 36 divided by 4 is 9. So I erase that, put in the 9. Now I'm down to a single set of parentheses, or a single number inside the parentheses. I can take away the parentheses. Do I have to put multiplication anywhere? No, there's already operations on both sides. So now I'm back out to the larger set of parentheses. In there, are there any other enclosing symbols? Yeah, we're coming over to this one. In there, what has to happen first? 21 divided by 3, which is 7. So I erase the 21 divided by 3, put in 7. What's next? 9 minus 7 is 2. Now I can get rid of the parentheses, but I have to remember for this one to put in multiplication. That's 3 times that 2. Now I'm back out to the bigger set of parentheses there, the yellow. What am I going to do first? Your multiplication and division is the highest priority in there right now. Perfect. 36 divided by 9, which is 4. Then the 7 times 2, which is, oops, sorry, not 7 times 2. I got to do the 3. I almost missed the 3 times 2, which is 6. Very good. Then it's the 7 times 2 for 14. Now, 4 plus 6, which is 10, minus the 14, which gives us negative 4. So I'm going to rewrite this just to make it a little more compact. Now I could now I'm down to a single number, I can get rid of the parentheses. Right now I'm going to leave them on there, not to be an enclosing symbol anymore, but just to signify that's times a negative 4, not minus 4, not subtract 4. My next step, however, is going to be to do that multiplication. No more enclosing symbols. That parentheses is no longer an enclosing symbol because there's nothing to do inside of it. No more exponents, so I have to do the multiplication. 7 times negative 4 is a negative 28. I'm using way more negatives here than I wanted to because we haven't really covered integers yet. That'll work. 9 plus negative 28 is a negative 19. Plus 5 is negative 14. Anybody actually get that to work? I may got a little carried away with that one. You were getting there?
Yeah.
Okay.
I messed up on I did 6 squared divided by 6 squared.
Okay. Okay.
I got 230.
Sure. That's not uncommon. That happens. We'll forgive it this time. Okay. The next type of problem I want to look at is going to look something like this. When we look at a problem like that, first thing we need to figure out is what does this line across here mean? Okay, divide. Yeah, everybody says divide. And it does mean divide. It's called a fraction bar, and dividing is one of the things it does. But it's also an enclosing symbol. It separates the top of the problem from the bottom of the problem. So it's saying that we need to do everything on top first. Then we need to do everything on bottom. And then we need to divide. So we're going to start out on top. We have 8 times 7 plus 2 to the third. Up there, what do we have to do first? 2 to the third, which is 8. Then what? 8 times 7 is 56. And finally, 56 plus 8 is 64. So the top of this is 64. On bottom, what do we have to do first? 5 squared, which is 35. And then 8 times 12 is 96. And then 2 times 25 is 75. And then 96 minus 75 is 21. Minus 5 is 16. So the bottom is 16. Now we have 64 divided by 16, which is 4. Not so bad. I'm going to scroll back up to this one quick. By the way, on this problem, the biggest mistake I'll see people make, and I'll catch at least one of you on a quiz or test doing this, is, oh, 9 plus 7 is 16. What's wrong with that? Yeah, it doesn't follow the order of operations, exactly. Unless it's the first number or the last number in these, every number has 2 operations, one going before it, one coming after it. This 7 does have the addition in front of it, but after it, it has multiplication. Which one has higher priority? Multiplication. So we cannot do the addition until it does the multiplication. That 7 cannot do the addition until it does the multiplication. It has to take the side of itself that has the highest priority first. I will catch at least one of you, though, doing that. So be careful. I'm going to have you guys try one. Try that one, Craig. Where do we start? Do the top first. Up there, what has to happen first? 5 times 3 is 15. And then 7 times 3 is 21. And yeah, 15 plus 21 is 36. Then what? 2 times 8. And then, well, enclosing symbols go first. So the 5 squared's got to wait yet for a while. So now we got to add in here. 3 plus 16 is 19. I'm going to take out the parentheses at the same time because I'm down to a single number. Don't need to put in any operations. Now we can do the 5 squared. 25. 5 times 5. Minus 19 is 6. 36 over 6 is 6. A little bit different form of a problem for you here. What's that? If you haven't learned by now, I always make it worse. It's kind of what I do. Okay. Looking at this one, we see this here. That symbol is technically called a radical symbol, but we know it more commonly as square root. For most of what we do, we're just going to do square roots. We're not going to get into, well, we might look briefly at cubed roots, but we're not going to do a whole lot with like 5th or 4th, 5th, 6th roots or anything like that. We might mention them just to show some patterns and show you the concept, but we're not going to do a whole lot with them. Square root, you guys kind of know what that means. We'll go over it more as the course goes on. But it's also an enclosing symbol. So that means we have to work inside of that first. So inside of there, no other enclosing symbols, no exponents. So we're going to do multiplication and division. We have 9 times 7 is 63. Now all that's left in there is the 1 plus 63, which is 64. I hope so. Now that we have everything inside that down to a single number, we can get rid of the enclosing symbol. The difference between this and a parentheses is, though, when we remove the square root symbol, we have to do something. So what's the square root of 64? 8. Just like the parentheses, however, that 3 in front of it, we have to put in a multiplication. Now, 3 times 8, 4, and 5 plus 24 is 29. Any questions?
What did you divided 64 and divided by 3?
Nope. 64 square rooted.
What times itself? Oh, yeah.
What that symbol means is what number times itself, or what number squared, equals 64.
Yeah.
So 8 squared is 64. Technically, negative 8 could be an answer too, but we're going to concentrate on positives. Plus or minus 8, yeah. Positive or negative 8. In your little book, Unit 5, and of course it's implied, whenever I say a unit out of the little book, it's implied the odds, unless I say otherwise. In your big book, page 24, 1 through 33, the odd. Now, especially on this page in the big book, do the first couple. If they seem really easy, skip ahead a few, just like I've said before. Make sure you're looking over your answers. I'll give you the last 13 minutes or so here of the first hour to get started on that one. Then we'll take a break and we'll start our second hour.